All right, so we talked about substitution and elimination, solving systems of equations, and now just to cover kind of all our bases, we want to look at what could happen. These are special cases for systems of equations. The situation you see currently, intersecting lines, so lines that are going to meet. One solution meaning, remember, we're looking for where the solution is, where do these two lines intersect. So characteristics you notice about the two lines, if we're thinking about linear equations, especially here, they have different slopes, and they may or may not have the same y-intercept. In this case, they have two different y-intercepts, but the different slopes is the important part here. In order for these two lines to intersect, they're going to need to have different slopes. So what else could happen? Why do we say there's special cases here? Well, what happens if our lines look something like this? So characteristics of these two lines, we're looking for where they're going to intersect. But if we're looking at these two lines, they have the same slope, but they have different y-intercepts. So this is considered a special case because how many times are they going to intersect? How many solutions are they going to have? Well, these parallel lines end up having no solutions because they never are going to meet. So no solution meaning no intersection. If they don't intersect, then there isn't a possible solution. There's no answer that we could be actually looking for. The other case, and this one's kind of hard to tell because you kind of think you only see one line there. But actually, what probably should be done on this page is to color a different line. But what this is actually two lines that have the same slope and they have the exact same y-intercept. So if I kind of drew another line, and this is supposed to be on top of this first line, these two lines have the same slope, have the same y-intercept. In other words, they're the exact same line. What we call that is coincident, coinciding lines. So with coincident lines, lines that are the same line, they're going to have an infinite number of solutions because you think, where are these two lines intersecting? Well, here and here and here and here and here. An infinite number of places. That doesn't mean that any possible numbers will work, but the answers, there's an infinite number of answers. So there's a difference, though, between being any possible numbers and it being just an infinite number of solutions. So if you look at, like, the point 3, 1, that's not a solution because it's not on either line. But the point maybe -2, -3, and the point 2, 3, and then we could keep, if we kept stretching those lines out, we could see lots and lots of points. There's lots of answers, but not just any answer will work. So what does that look like? We're not doing a whole lot of graphing. What does that look like when we're actually doing solving, substitution, elimination? Is that you're going to see either one of three cases. The one solution case, the one we looked at first, where the two lines intersect, that's where the cases we did in class. And then with Khan Academy, you're solving and you get an x value and you get a y value, and there's nothing weird that kind of happens. If you have no solutions, we'll see a couple examples here. What's going to happen is, whether you're substituting or eliminating, both your variables are going to cancel out. Your x's cancel out, your y's cancel out, and you're left with a false statement. And by a false statement, what I mean is something that should be pretty obviously not true. Something like, for example, you're left with 1 = 5. You're left with something that is completely not true in any way. 1 is never equal to 5, so that means there's no possible solutions. If there's infinite solutions, what you'll have is that the variables both cancel out, and you're left with a statement that is true. So again, something that's obviously true or obviously false. 1 is equal to 1. It's not that it gives you a lot of information, or not groundbreaking information that, oh, 1 is equal to 1, but it's telling you that these two lines are coinciding lines. So if there's no solutions, that's when we're talking about the parallel lines. And when there's infinite solutions, we're talking about the coinciding lines. So if we look at this case on the left here, How are we going to solve this? Well, you have to choose your method. It's x equals, so I'm going to choose substitution. So if I substitute that in for x, 3 times 2y minus 7 goes in for x, minus 6y equals negative 21. 6y minus 21 minus 6y equals negative 21. And you notice here, I plugged in for x, so my x's are gone now. And I'm left with 6y minus 6y. If I combine those, they cancel out. So I'm left with negative 21 equals negative 21. Well, which situation does that match? That's the situation where I have a true statement. True statement, so that means there are infinite solutions. Not that any numbers will work, but that there's an infinite number of combinations that I could list out. So true statement, infinite. False statement, you say to yourself, no, that's not true, so there's no solutions. So let's look at one more here. What's going to happen with this particular one? Well, looks like to me both these equations are in standard form. Say to yourself, what method would I like to use? Well, looks like elimination would be the best method to choose. So you say, okay, this says negative 6, but I want to eliminate the x's. This says negative 6x. I really wish that this top number said 6. So what am I going to have to do to get that to say 6x? I'm going to have to multiply the entire top equation by 3. So 6x plus 3y equals 15. On the bottom, I keep the equation the same. Negative 6x minus 3y equals 7. And now I can add the two equations together. 6x minus 6x cancels. 3 minus y minus 3y cancels. So I'm left with 0 on the left side. And on the right side, I'm left with 15 plus 7 is 22. You say, okay, my variables both canceled out. I'm left with a false statement. So that means it's not true, means there's no solutions. So in this case, we'd have 2 parallel lines. So these are just the special cases that can occur, so you're prepared for any situation involving substitution and elimination.